Hello guys, welcome to the class again. Let me take my good morning guys. So today we are going to continue this class on the linked list. So before I start today, let's recap what we have learned in the previous class. Okay, so let me okay. Is it fit? It is fitting into this one? Yeah. Okay. Hmm. So in the previous class, previous class basically, we understand what is linked list, right? And we also discuss what is the difference between the linked list and arrays in terms of the structure. Correct. Then we discuss about what are the different applications where linked list has been used, like hash map, file system, adjacency list. These are the topics or these are the applications, concepts where internally it uses linked list, right? And then we also talk about the structure of the linked list, right? Where it has two pieces. One is the node and other pieces is the connecting of the node, right? So in the linked list, we will have multiple nodes, all are connected with each other, right? How it connects to each other? So each node has two parts. One is the data part and other is the address part, pointer. We call it pointer. And that pointer basically holds the address of the next node. That is what we discussed in the previous class. Then also we have visualized that how this sequence of nodes can be formed or can be created, right? And then we also discussed about how we have implemented the linked list. To implement the linked list, we need two classes. One is the node and the another is the linked list classes. So where Okay, so node class basically is a particular node that contains two data members. One is the data that you are going to store and also the address of the next node, right? So these are the things we have discussed in the previous class. And also we have touched upon the generics, though it is not part of the scope of the linked list topic, but we have discussed and highlighted certain points about generics, meaning what is the T represents here, right? And what does T represents? Can we use another letter instead of T, right? These are the things we have discussed in the previous classes. And also we have discussed how this T is replaced at the runtime. Correct. How this T is replaced at the runtime. Okay, hold on a second. Let me just rearrange this one. Okay, now it's perfectly fitted here. Okay. Okay. How is T replaced at the runtime? If you declare or create a integer node, then at the runtime, your T will be replaced with the integer. And if you are going to create basically this T, right? Uh, when you create a string node, right? Then T will be replaced with the string. That is what we have discussed in the previous classes. So now also we discussed about how will you implement the linked list classes. While discussing the linked list class implementation, we also touched upon the inner class perspective. So here your node, this node is your inner class, right? And it also contains the head node and size. We also talk about what is the head node here. Basically, it points to the first element of the list, right? These are the basic concepts we have discussed in the previous class. Now let's move on. And also we discussed and touched upon the more details of the head node, right? In this particular class. Now let's move on. Now, again, also we discussed, though it is not into the scope of the linked list topic, we discussed about the concept of the uh, inner class, right? Because in the singly linked list class here, we have defined this node and we touched upon static versus non-static classes, correct? Now, we also um, discussed about what will happen if you write node T, right? So, though it will not give you the compile error, but it's a bad design and it creates confusion, poor readability, and that potential bugs, right? This is all we discussed in the first class of the linked list. Now, also we discussed about how the compiler actually sees your code. So when you write, let's say singly list integer, right, then your node becomes node integer. If you create with a string, if it is a string, then it will be a string, right? This is what we discussed in the previous class. Now, we also touched upon why do we need node T, where we exactly need this one, right? So while discussing, we understand that if you are defining it as a top level class, then you need to define this generic. If you define as a non-static inner class, that is where you don't need to define because it will inherit from the top level classes. Okay, and then that is what we discussed yesterday till now. Okay, now let's discuss about what are we going to cover today in today's class in the perspective of linked list. So we understand that to store a collection of data, right, we can use linked list. And in the linked list, we have a node, one node, right, that contains data and pointer to the next node, right? And similarly, the next node contains pointer to the next node. Okay, so this is what we discussed. If I will give you the analogy, think like this one. When in the train you have a compartment, right? Each compartment is connected with each other, right? And there is a at the first compartment is nothing but your engine, right? That you call the head node, right? Now, so all are connected through a chain, right? So you can think like this way. Okay, so far with me? Okay. Now,
Yes.
what are the basic operations that you can perform in the linked list? Okay, so think like this one. If you have a collection of data, right, what are the operations you can perform? See, either you can insert more data, right, or you can delete some data, right? So these are the operations you can do, or either you can search the data. For an example, let's say um, Amazon or Flipkart, you can search the data, right? And the admin can add data, let's say mobile phone, they can add one more stock to that one, right? So these are the basic operations that can be performed on the list. Okay, now, so in terms of the basic list linked operations, so first one is the insert, right? Insert means you are putting or adding new data into the linked list. So when we say insert, so you can perform insert at the end of the linked list. So let's say if you have an existing list, you can add the new data to the end of this linked list, or you can add this data insert at head, right? So insert at end also you can consider it insert at tail, right? At the last node of the list is nothing but we called it tail. Got it? Now the other operations you can perform is delete, right? So delete means you can delete the data, right? So if you look at this one, you have a delete and we pass data here. You see here, we pass data here. What it represents? It represents that you have a already existing linked list and you wanted to delete a certain data. So which data you want to delete? So that is the reason we pass data. Delete at head. Delete at head means your head represents the first node of the linked list. So that means you wanted to delete the first node. That is the reason we are not passing any data. Delete at head means you already know that, okay, I need to delete the head means the first element of the linked list, I need to delete it. Delete at end. In the linked list, you also don't need to pass data, right? Because you wanted to delete the element at the end of the list. Whatever the last element is there, you wanted to delete that. Okay. Now, the other operation could be search data. So if you have a linked list, let's say linked list of integer 10, 25, 30, 100, 200, whatever the data is, right? Now you wanted to perform search operation in the linked list. So how will you do that one? So this is one of the operations we can perform, right? And there is another helper method we can say is empty, whether the linked list is empty or not, right? So this is very important method that we will discuss about is empty. Okay, and the other operation or functionality you can see is find length. So you have given a length, sorry, you have given a linked list, then how will you find the length of the linked list? So that is where we will cover this part. Okay, so far with me guys. Apart from this, there are a lot of other operations, okay, that we can also learn and we will solve a lot of problems related to linked list. Okay, now to solve those problems of the linked list, you must be aware of these basic operations, how you can code it. Right. So before code it, you need to understand these basic operations, how it works. You need to build an intuition. You need to visualize this one. Then only you will be able to do that one. That is the reason I am emphasizing more on this part. Okay, this basic operation. With that, now let me move to the next section. So the first part, the first part we are going to do is the basic operations is, let's say, or you can say helper functions we are going to discuss about is empty method. Is empty we are talking in the context of linked list. So you have a, let's say, nodes, multiple nodes, all are connected with each other, right? So right, that is a linked list. When we can say that linked list is empty, means there is no node in the linked list. So that is empty function. So helper function, it will be used in other basic operation. Whenever we will do the other basic operation like insert, delete, it may be used there, right? So that is the reason first we are going to discuss empty, right? Remember that in the previous class we discuss and talk about a linked list will be empty only when head points to the null, means your head node points to the null. So I also mentioned that whether linked list exists or not, your head node will exist, but it points to null when your list is empty. So far with me guys on this statement. Are you with me on this statement?
Yes, sir.
Okay, perfect. Now, I mention here, I will share this note, guys, to you guys. So that is the reason I'm preparing this note. I will recording this one. I will share the record as well. Okay, give me some time. I'm working on that one. I will do that one. Even when a linked list is empty, the head node must always exist. That we also discuss about. See, these are the concepts you need to put in your brain, because it will make you, while solving the bigger problem or a harder problem or medium type problem, these are the concepts that will help you to derive the solution. Believe me. Okay. So even when a linked list is empty, the head node must always exist. Okay. Now, how will you implement this one? So we are going to take this class, singly linked list class, as a baseline. Okay. This singly linked list class as a baseline. So meaning this will be fixed. We are not going to change. And on top of that, we will be building all the operations. Okay, and in those operations we will be basically using these variables that is defined inside this class, right? So if you look at this structure of this class singly linked list, you have a class node that is an inner class, this node, and it has a data part, and also it contains the pointer or address to the next node. Okay, that is what it holds. And also in this since we are talking about this singly linked list class, so we have a head node, right? And that head node represents or indicates or points to the first node of the linked list. And also we are mentioning here size. What is the size of the linked list? Okay, and we define a constructor here, singly linked list. So constructor makes this class operational, meaning whenever you create an object, initially your head node will be null. Why? Because at the starting of the implementation, you don't have any node. We are going to create the node, or we are going to add the node, right? So that is the reason your head node is null. Since your head node is also null, that means size will be 0, because whenever you are saying your head node is null, that means your list is empty, and when your list is empty, that means your size will be 0. So far with me, guys? Now, how will you implement this empty function? So you are checking whether linked list is empty or not, right? So that is the reason the return type is boolean. That is the reason return type is boolean, means either it will return true or either it will return false. If your linked list is empty, right, it will return true. If it is not empty, means if it has at least one node, that means what?
Return false.
That means return
False.
false. Okay, now how will you implement this one? When you say that your linked list is empty, tell me, Chitish, when you say your linked list is empty,
When head node points to null.
sorry.
When head node points to null.
Yeah, when head node points to null, meaning when your head node, you see here, this is the head node, right? You see here in this singly linked list class, you have a head node, and this is the variable we are using here. If head node is equal to null, that means if your head node points to the null, so that means your list is empty. Otherwise, it will return false. So far with me, see how easy to implement this one. If your head node is null, so that means it return true, otherwise it will return false. Right. So now tell me, if you don't know the concept, if your head node is null, that means list is empty, then you won't be able to implement this one. Right. So this is the concept intuition. If your head node is null, meaning there is no node into the list. Right. That means the size is zero. So and your it will return true. And the time complexity is 1. I will discuss more about later on, but the time complexity represents how much time it will take to compute this code or execute this code when your input increases. Let's say for an example, if you have a 100 nodes, okay, will the execution change versus if you have a 2000 node? No, right? It doesn't depends on the node, right? It is just checking if your head node is null, it will return true, otherwise it will return false. So far with me, guys?
Yes.
Yes.
Are you with me?
Yes, sir.
Okay, perfect. Now, shall we move on? Okay. Now, now the next function we are going to talk about is the how will you implement find length, meaning you have given a head node. What you have given? You have given a head node. Okay. How will you find the length of a linked list? How will you find a length of a linked list? Correct. How will you find the length of a linked list? So, to find the length of a linked list, what you need to do? We need to traverse the list. We need to traverse the list. Okay. So, for an example, same analogy, you have a train has an engine and other compartments all are connected with the train. Okay. Now, if you wanted to find the length of the total compartment, okay, from where you will start?
Engine.
Engine. Why? Because engine is the starting point, right? If let's say if engine is not there, then from where you will start you don't know, right? So engine is the starting point. So far with me? Correct. So that means you need to know the head node. If you know the head node, then from the head node you can find what? You can find the length. How? So when you start from the engine, you will see, okay, from engine, this is the one compartment. From here, this is the another compartment. Right? This is the second compartment, third compartment, fourth compartment, fifth compartment, sixth compartment. Till now you will go. Okay. When will you last? When will you last? You will last when you reach at the end of the compartment, there is no connectivity, right? There's no connection at all, so that is the end of the end of the list, right? So when you meet or when you reach to the end of the list, so till that time whatever the count you have, that is the length. So far with me, Ritik,
Yes.
Kishan?
Yes.
Okay. Now,
Yes, sir.
so how will you implement it here? What you have given? You have given the engine. You have given the head node. You have given the head node. Okay. Now, so this is the function, right? Public int find length. You pass the head node. What is the head node? If you look at this one head node, where is the head node? This is the head node, right? My bad. This should be node. This should be node. Okay. This should be node. Give me a second. This should be node. Okay. This should be node. So you have given the head node. You need to find the length, and you know the engine, where the engine is, head node. Okay. So now you have given the head node. So again here I need to change this one. Give me a second. This is wrong. This should be what? This should be node. Okay, this should be node. This should be node. Okay, this should be node. Now, let's move on. So you have given a head node. You have given a head node. So now, when you start from the head node, means you are starting from the engine. At that point of time, what was the length? 0, right? So that is the reason we have defined length as a 0. Length is 0. Okay. I think here this is wrong. Let me take this pencil. This is wrong. It should be node. Okay, now let's move on. So what is, guys, give me a second. Okay. This should be int length, node, current node. Okay. So we are going to find the length of the linked list, and we have given a head node. We know that head node. So whenever you start with the engine, right, that we called head node. So your length is 0. Initially length is 0, right? Now, what we are going to do here is this head node, right? We are going to assign this head node. Always do this one. I will talk about this one later on. Current node. What you are going to define? You are basically defining creating a, basically assigning this head node to this current node. Okay, for an example, let's say you have this 2, 4, 6, 8, right? This is your head node. This is your head node. What I am going to do here is I have a current is equal to head. What it is going to do here is current is equal to head. So I have another node, same variable, and it also points to this one. It also points to this one. What I am saying here is whatever the head node you have given, it is given, you should not touch that one. You can assign that head node to the current node. Okay. And then iterate the current node. So that means when this line execute, when this line execute, So that means at this point of time, this current node also points to this one head node, because you are saying head node is equal to current node. So far with me? Got it, guys, right?
Yes.
Now we will iterate this current node. What are we going to do? We will iterate this current node. Okay. So what we are checking, till which time we need to iterate? When will your list end, or when will your train ends? Trend, you have a train example I've given, right? When you reach to the last, that means there is no link, right? No link in terms of linked list. When your head node, that we called it current node, when your current node is not equal to null, till that time you will go and check. Okay, let's say you start from the engine. This is your engine. You start from the engine. Whether engine is connected to any compartment. Yes, it is not equal to null, right? It is connected. So then we will go to the next compartment. Is next compartment connected to other compartment? Yes. Is the next till the end, right? When it becomes null, so that is where you will break this loop. So while current is not equal to null, right, till that time you will go and iterate this loop. And whenever you go inside this one, right, so that means you found a one compartment, and that time you will increase the length. Ritik, what happened?
Hmm.
Okay, you are getting, guys, right? So here 2 is your current node. So where we are checking whether 2 is 2's, where this node is connected to the next node or not. It is connected, right? So that means it will go inside and it will increase the length. So length become 1. Then it will again. Now, what is your current now? Current dot next. Let me write this one. Mm, okay, let's understand this in a better way. Okay, so let's say this is two. Who is sleeping? 4, 6, 8, and this is null. Okay, now these are OR node, but how this node you can represent? Like this one. 2, this is node, right? It has two parts. And let's say this is null. It has two parts. One is data part. And what is this one? Pointer. Let's say this is 4, pointer. This is 6, pointer. Okay. Now, when you iterate this one, while current is not equal to null, what does it mean? What it is checking? Whether this is your current, right? This is your current head node. Is it connected to the next node?
Yes.
How will you check whether current, what is this one, node is not equal to null, right? It is connected here. So that means you increase the length 1. So now length becomes 1. Now what is this next statement? What is this line doing? Now you are saying now current is equal to current dot next. So this point of time, where is your current? Here. Now, when you assign current is equal to current dot next, what is the current dot next?
4.
This one, right? So what you are saying, current, this is your current, this is your data. Look at this, guys. Next node, you have a next node here. This is the data, right? What it represents? Next node, it is a node, right? That is into the linked list. So what you are saying here, current is nothing but your node. Now, correct? So current dot next, current dot next, where it will go? This
At
here
4.
at 4, right? So now instead of current, earlier current was here, now current becomes 4. Current is here, right? It will go again here, it is checking. Now this is your current now. This is your current now. Okay, now current is not equal to null. Condition true, then it will come here, length becomes 2. Length become 2, right? Then again, now current dot next. What is the current dot next here? This is your current, right? At this point, current dot next means this one. What is this one? This is the address of this node, right? Now then current becomes what? This one. Did you get? Chitesh, Ritik, Kisan, all the guys?
Yes.
Okay, so what happened? Now it will let's say it reaches here. When it reaches here, let's say this is the end of the list. Think this is the end of the list. End of the list. Now what is this represents here? Null, correct? So now when it reaches here, so current is not equal to null. What is the current? This is null, right?
Yes.
So when it is null, so that means it will come out of this loop and it will return length. So what is the length in this case? 3. In this case, it will be 4. So what we did here, so we have a head node, right? And we need to find the length. So since all nodes are connected with the chain, and if you know this is my head node, so you can iterate the head node till it is not null, then you will keep on iterating. Each iteration you will increase this length. Each iteration you will increase this length and also move the pointer to the next node, right? Now once it reaches to the end, so that means where it will be null and it will break this loop and it will come out. It will return the length. So far with me, guys?
Yes.
Okay, shall we move on? Is there any doubt, Kisan?
No, sir.
Ritik? Ritik?
No.
Okay. Is it boring class?
No.
No, sir.
Then why are you sleeping? Who is sleeping? I know. Okay. I will ask all these things later on, okay? Now, let's talk about the main basic operation. That is another one. It is insert operation. What are we going to discuss? Insert operation. So again, we will, before jumping into the coding part, let's build the intuition, let's build the concept. Once we build the concept, then it will be easy for us to solve the problem. Guys, are you with me?
Yes.
Okay. So now when we talk about insert operation, so insert can be performed at 3 different places. One is insert at head, right? Let's say if you need to insert at the head, what does it mean? It means you wanted to insert as a first element of the list, right? That is your head tells. Insert at end means insert at the last element, right? Means tail of the list, tail of the list. And insert after an element. Let's say if you have given 2, 4, 6, 8. Now you wanted to insert an element, let's say 20 after 6, right? So there are three different flavors of insert operation. Okay, are you with me, guys? Are you with me?
Yes.
Okay,
Yes, sir.
now let's talk about insert at head. We will go one by one. Today we are going to discuss about insert at head. This is very, very crucial to understand the concept and build the intuition. I am repeating it again and again. Now, insert at head. Insert at head means insert a new element as the first element of the list, right? Because your head points to the first element of the list. So whenever you wanted to insert a new element at head, that means that will be the first element of the list. Since head always points to the first element of the list, right? That is the statement I've given. Insertion at head means we are going to insert the first element in the list. That is what we are going to discuss about. So how will you build the intuition and visualize? Let's visualize this one. So initially your head is pointing to null. Initially, let's say your linked list is empty. So your head always exists, right? And it points to null when your linked list is empty. So your head points to the null. Your head points to the null. Now you wanted to insert operation. Let's say you wanted to insert 1. The data is 1. So initially your head points to the null and you wanted to do a insert of 1. Right? Then what will happen? Now earlier starting of the linked list, since it was empty, it was pointing to null. Now your head will points to 1. Right? Because since you are going to insert 1 at head, so that means 1 will be the first element of the list, right? And then after that this 1 points to the null, correct? So 1 become next element of head. 1 become next element of head, or you can say first element of the list. So far with me, guys?
Yes.
Okay. Now
Yes,
let's
sir.
say you have inserted 1 already. You have inserted 1 already, right? At head. That means 1 is the first element of the linked list. Now you wanted to insert 2 on this one. Insert 2 where? At head. So then how it will look like? How it will look like?
Head 2 1 null.
Because you wanted to insert 2 at head, so 2 will be 2 will be the first element of the list. 2 will be the first element of the list. That means your head will point to the 2 and 2 will point to the next element. That was 1. So 2 becomes next element of head and 1 become next element of 2. So far with me, guys? Is there any confusion here?
No.
So whenever we wanted to add or insert any element at head, that means that will be the first element of the list. Okay? Now, how will you implement this? We build the intuition. Now we are going to implement this one. So what we are saying, insert at head. insert at head, insert at head. Okay, and the data is given. What data you need to insert at the head, that data is given. That data is given. Let's say here we were inserting 1, right? Here inserting 2. This data is already given here. This is the data. Correct? Now, how will you insert at head? So create an, okay, the very first step is you need to create a new node because the data is only given. What part you have given? See, what part you have given? Only the part you have given is the data. This data part you have given, right? But data is not that is connected to each other. The node that is the node that is connected to each other. So with that, let's say you have given a data, right? You want to insert this particular data, let's say 2, 4, 6, any data you want to insert. So with that data, you need to create a node first. You need to create a node first. Once you create the node, then you need to link the node. Means you need to put that node at the as a first element of the list. Okay, let's discuss. Create a new node and assign a value to it. So how will you create the new node? You know, right? Node is a class, though it is an inner class, node is a class, and this is the variable new node and is equal to new node. So what it will do? It will just create a new node. It will just create a new node. Okay, and this, let's say this is your new node. Okay, let me draw it. Let's say this is your new node you have created. This is a new node you have created. And new node, this is your new node. Okay, two parts. New node dot data. What is the pass? What you are passing? Data here. Let's say if you pass 6 here, so that means 6 will be assigned here. So now your new node is created. Now your new node is created and you assign the data. So first part you have done. Create a node and assign value to it. So far with me, guys?
Yes.
Okay. Now, linking head to the new node's next node. Now you need to link this. Basically, you need to link this node as a head node or first node of the list. Why? Because you are inserting at head. So how will you do that one? So this is the new node, right? So new node dot next node. What we are saying, new node, this is a new node, and this next, it will pointing to the head node. It will point to the head node. That is what we have defined. So that means your head node will be assigned here. This is the pointer, right? And then and then and then your head node, right, will be the head node is equal to okay, not this head node is equal to just node, new node. You will assign this one. And then since you are adding a new element, so you are going to increase the size. So far with me, guys?
Yes.
Okay. New node dot next node is equal to head node. New node dot, remember this one, new node dot next node is equal to head node, and head node is equal to new node, right? So this is a doubt. Did you get this part? I believe you have not get it clearly. New
No.
node dot next node is equal to head node and head node is equal to new node. I think this part you have not get it clearly.
Yes.
Okay. Yeah, I know that. Now let me clarify. This is the very important concept in the linked list. This is the very important concept. Okay, let's understand this part. Now we are just going to understand these two lines. We are just going to understand these two lines. This is very crucial. Okay. Now, what is the goal here? The goal of insert at head means insert a new element at the beginning of the list and make it the first node. That is our goal, right? The goal of inserting at head means insert a new node. Whatever the new node we have created means insert an element at the beginning of the list and make it the first node of the list. So far with me? Now, that is our goal, right? Keeping that goal in mind, let's understand this one, how actually it works. That is the important concept. Let's keep in mind this two line. New node. So you have created a new node, and what we are saying, new node dot next node means whatever the node you have created, that node's next node, we are saying that that will be the head node, and then we are assigning that head node, that whatever the new node we have created, that is assigning to the head node. Okay, that is what we have done. So let's understand this one. So visualize. How will you visualize? Think like this one. Assume okay. Assume the list already looks like this one. Let's assume that one. Let's assume this one. The link list, your list looks like this one. So you have three elements into the list: 10, 20, 30, and 30 is the last node of the list because it is pointing to null, and 10 is the first element of the list, or you can say the head node of the list. 10 is the head node of the list. So far with me here? Let's assume this one. Let's assume this one.
Yes, sir.
Okay, now Chitesh, Chitesh,
Yes.
do you understand this part?
Yes.
Okay, what I said, assume your list is already looks like this one, means it has three elements: 10, 20, 30. 30 is the last node of the list because it pointing to the null, and this is the first node of the list, so that we called it the head node. Okay, now stay in step one. So in step one, what we did, we created a new node, and that new node, we assign the data, whatever the data. Let's say if you wanted to insert 5, right? Then we will insert 5 here. See here. That is the part I'm trying to discuss it here first. Okay. So when you create a new node and you assign a data, how it will look like? In memory, in computer memory, in RAM, it looks like this way. It looks like this way. So this is your new node. Let's say if you wanted to create a new, and let's say data is 5. So your new node will be like this one. Node, and this will point to the null. In memory, it will look like this one. When you execute this part only. So far with me,
Yes.
Ritik,
Yes.
why here null? Because you have created a new node, brand new node, and you just assign the data, but you have not done anything with the pointer, that address. It has two part, right? It has two part. First part is the data part 5 that you already assigned. The second part, right? This second part, you don't have anything. So that is the reason it pointing to null, right? And exactly it will look like into the memory, computer space, memory, right? So this is the new node. So far with me, guys, on the step one.
Yes.
Okay.
Yes, sir.
Now, in step two, this is important. Now, new node. What is your new node? This new node. I am just talking about. This is the data part and this is the address part. So, new node, the next node of this new node means next node of this new node is equal to head node. Why? The new should point to, okay, let's understand this part. When you, what is the, okay, before 5, what was the list before 5? This was the list. Before 5, this was the list and head node was pointing to 10, right? 10, 20, 30 was presenting 10, 20, 30, and 30 was the null. So this was the existing node. So far with me, guys?
Yes.
And where is your head node pointing?
At 10.
10. This is your head node, right? Correct. Now, when you execute this line, new node dot next node, what is the new node here? 5.
5.
What? 5 next node. This node's next node, what we are saying? Head node. That means it will point to this one. It will point to this one. We have still not done. Wait. Right? So this is your new node. This is your head node. When we execute this line, that means this new node points to this one. So far with me?
Yes.
Okay. So the new node should point to whatever node was previously at front, or connect the new node to the existing node. See, this node is this list is existing, right? And this node is existing means this node already exists where head node is 10. This is the newly node created, right? And it points to the, basically it is in the memory. But this and this node are in the memory independently. They are not connected to each other. To make the connection, what we are doing, we are saying next node means address of this new node should equal to the head node. It should point to the head node. What is the head node? So this is the one. So that means at this node address should point it here. That is what this line is doing. So far with me, guys? Okay.
Yes.
Yes.
Okay. Now, if we don't do this one, think always in the opposite. If you don't do this one, right? So that means though its node is there is no connection and it will be lost. If you create a node and if you don't connect, it will be lost. Why? Because you don't know where it is created. Remember, the only way to access the linked list is the head node, the first node of the linked list. Okay, now let's move on. Still we have not done. So I mentioned this point here. When you create a new node, this node is not connected to the list 8. If we stop it here, it would be lost. To make the connection establishment, we need to execute this one. What exactly this line is doing? Whenever whatever the new node you have created, those nodes next node means the second part address of this node will point to the head node. That is what we are doing here. Okay, now let's move on. Now the question is, why do we do this before change? Why do we do this before change? um, changing. Okay, I think changing head node. Okay. Why do we need this before? Okay. Hold on a second, guys. Um, okay. So in this code, let's understand this part. So you got this part, right?
Yes.
You got this part, right? It is just creating a new node and assigning the data to the new node. And this is the linking part, linking head to the next node. So you understand this part, right? New node dot next is equal to head node. You understand this part, right? Then after that, what you are saying, head node is equal to new node. I will explain this part also. Head node is equal to new node. Okay. So first you will do new node dot next node is equal to head node, and the second statement what you will do, head node is equal to new node. What if it will, what will happen if we reverse this one? That is the part we are going to talk about. This is very, very crucial. So why do we do this before changing head node? Okay, now let's say for an example, if you do like this one, head node is equal to new node. Let's say if you do head node is equal to new node, and then after that you do new node dot next node is equal to head node. What we called it, wrong order. This is wrong order. Why it is a wrong order? Sorry, why it is a wrong order? Why can't we write like this one? There is a problem here. What is the problem? What is the problem? Once head node changes, you will no longer know where 10 watch or 5 watch. Okay, let's understand this part. So what we are going to, what we have done, new node dot next node is equal to head node. I believe you guys understand very clearly this line, right? Now let's say
Yes.
if we don't do this line, if we don't do this line, or let's say if we do this line before this one, head node is equal to new node. Let's say if we do head node is equal to new node. Okay, let me write it. Let's say if we do here head node is equal to new node, and then after that if we do this one, what will happen? Let's say if we, what will happen? So this is the list that is already existing, and head node here is 10. Correct? Now if you do head node is equal to new node, what will happen? You know what will happen? Head node is equal to new node. So means what you are saying is, now head node points to this one. Head node is, when you say head node is equal to new node, head node points to this one, right? Not getting?
Getting it will replace the earlier head node and the whole list.
Whole list. Meaning you don't have, then your this list will be lost. This list
Yes.
will be lost. Correct? So, see, in so in in Java, let's say if you have int a is equal to 20. Okay, what is the value of a?
20.
20. I'm just giving a maybe wrong example, but to make you understand. Now, if you now now a is equal to 30. Now this value will be lost, right? Why? Because it is overridden by this one. So far with me, guys?
Yes. Yes.
Right. Now, if you wanted to take this value, you need to store, before assigning, you need to take this value somewhere else, right? So in a similar way, okay. Okay, in a similar way, so this is not right, because when you do head, so at this point, see, at this point, your head node, this node points to this one. Now, once you execute this line, your head node points to this one. Then this list is gone, right? So far with me? So that is the reason we said it wrong order. So this is wrong order. Once head node changes, you no longer know where 10 was. This, where is this 10? You don't know, right? Because you already assigned the new node. This basically, now earlier your head node was pointing to 10. Now your head node is pointing to 5. So that means this has gone completely. So that is the reason this order is wrong. Okay. Now, so when you do this one, right, so that means your new node is 5 and this is the head node. So this is the correct one. This should not be written. This should not be written. Strike it out. Okay, we reach here after executing this logic. We reached here. Okay, so that means the new node is connected to the already existing list, and your head node still points to the 10, and your new node is the first element. But what is the concept? Your head
First element
node,
is the head node.
yeah, your head node should always be the first element of the list. So that means at this point your head node is pointing to 10, right? Now it should pointing to 5, right? So now write this one when you write this step 3, head node is equal to new node. So what will happen? So 10, 20, 30, this was the connection, right? Earlier this was the head node. Now when you write head node is equal to new node, so that means your head node now points to here. Correct? Got it, guys?
Yes.
Your head node points
Yes,
to the
sir.
new node. So far with me?
Yes.
And the time
Yes, sir.
complexity is O1, because if you look at this code, right? So we are not traversing anything right here. We are just manipulating the assignment, means linking and unlinking. We are creating the new node and link that newly created node to the existing list, right? So that is the reason your time complexity is O1, because there is no traversal, no loop, and only pointer reassignment. Did you get this concept?
Yes.
How will you insert at end, right? So we need to do a lot of practice, then only you will solve a lot of problem. So in the next class we are going to talk about or touch upon the other basic operations. But believe me, if you understand this concept, then rest will be easy for you. Okay, guys? So with that, I'm going to end the class today, and tomorrow I need to go to office. So maybe um, we'll have the class at 8 o'clock. Okay?
8 o'clock morning.
Yeah. This time is fixed, guys. Just 15-20 minutes here and there. Okay? Just 15 to
Okay,
20
okay.
minutes here and there. But this timing of the class is fixed. Okay? No excuses. All right, guys. Thank you for joining once again. Thanks for learning. Happy learning. I wish you all the best. Okay. Bye bye. we'll share this YouTube video and also this recording later on. Okay, thank you.